This is question 2 on chemistry from the 2018 BMAT. So we're given two elements, Q and Z, and told how they appear in the periodic table. And we're asked what kind of bonding forms between the two elements and what's the empirical formula of the compound that we produce. So we're told how Q and Z appear in the periodic table, but maybe it would help even more if we can actually visualize them in the table. So let's do a quick sketch. We should know the general shape of the periodic table. Now, how do we figure out where Q and Z go? So we're given the atomic numbers, that's the 12 and the 9, and what do they tell us? That's the number of protons in each element, and therefore the number of electrons as well. And so given this, how do we put them in the table? Well, we know how electrons fill up. We have the 1s2 that takes 2 electrons, 2s2 which takes 2 more, then 2p6 which goes here which takes 6 electrons. So we can maybe begin putting Z in because it has the fewer electrons. We need 9, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, which takes us to group 17 here. So Z is a halogen. And now Q, we have 3 more electrons, so we go 1, 2, 3, which takes us to group 2. So now that we know whereabouts Q and Z are in the periodic table, can we guess what sort of bonding they form? Well, we know that group 1 or group 2 metals and elements that are quite far along the periodic table generally form salts with ionic bonding, like sodium chloride, for example. So we've got the bonding, now we need the empirical formula of the molecule that's formed. So what is this? Well, if we have ionic bonding, then what ions are going to form from Q and Z? So we know Q is in group 2, and what happens to ions when they form ions? They lose enough electrons or gain enough electrons to form the full octet shell. So Q is in +2, so if it loses 2 electrons, that'll give it the noble gas configuration of 8 electrons in its outer shell, so it will form Q2+. And what about Z? It's in group 17, so it's a halogen, so it just needs to gain 1 electron to give it the full octet to form Z-. So what's left to do? If we put these together, the empirical formula of the ionic compound, what's it going to be? QZ2. So 2 Z's for every Q to make a neutral charge. So our answer corresponds to C on the question paper.